Okay, we're coming back to the topic of computative function. As I spoke to you guys about earlier, composition of functions are not computative, and we've already proved that with an example where f of g of x was not equal to g of f of x. So the order in which the functions are applied in composition is very important. And just to give you another analogy what computative functions actually mean, or what computative property basically means, you can think about an example of shoes and socks versus hats and gloves. So the order in which you wear your hats and gloves does not make a difference, but the order in which you wear your shoes and socks does make a difference. You would have to wear your socks before you wear your shoes. Similarly, if you look at an addition and multiplication, the order in which you apply addition and multiplication function does not make a difference, but the order in which you subtract and divide functions does make a difference. So subtraction and division are not computative functions. Similarly, composition functions are not computative because the order in which they are applied does make a difference. However, there is an exception, and this exception is basically if you take a composition of a function with its inverse, the order in which that is applied does not make a difference. So f of inverse of x is also equal to f inverse of f of x. So the order in which you apply the composition of f and its f inverse, or f inverse and f, does not make a difference because the value or the end result will just end up being x. So one thing to note here is that f of g of x equals, if f of g of x equals to x, then for sure you can see the fact that f and g must be inverses of each other. Okay, and we are now going to do the last example just to wrap things up here. Here I'm given a different function, f of x is equal to 2x plus 3, and g of x is equal to square root of x squared minus 5, and I have to determine f of g of x. Again, I'm going to go ahead and replace this circle with a bracket, so f of g of x. G of x here is equal to the square root of x squared minus 5, so just going to replace that with x squared minus 5. And now I'm working with a function f, which has an input of square root of x squared minus 5. So anytime I see x in the function f, I'm going to replace that with the square root of x squared minus 5. So that is equal to 2 times square root of x squared minus 5 plus 3. So just expanding that out, that's 2 times square root of x squared minus 5 plus 3. So f of g of x is equal to 2 times square root of x squared minus 5 plus 3. And part B of that just basically says that I have to figure f of g of 9. So I'm replacing that x with a 9. I have to determine the function f of g of x, and I'm just going to use that function. So f of g of x is basically equal to 2 times the square root of x squared minus 5 plus 3. And I'm now going to determine f of g of 9. So replacing that x value with a 9. So anytime I see x in this function, that is now going to be replaced by 9. So it's just 2 times square root of 9 squared minus 5 plus 3. That's 2 times 9 squared is 81 minus 5 plus 3, which is 2 times square root of 76 plus 3. And I'm just going to leave it as that. Okay, and just to let you know about your assigned work for this lesson, you are to go through on page 446 to 448, and you have to do communication number 1. You have to do question number 1 to 4, 5 to 9, 14, and 17. And you have to watch the video for lesson 4, which is the inequalities of combined function. This right here we will do in class tomorrow, and your homework for tomorrow is to watch the video for lesson 4. That's regarding inequalities of combined functions. Be sure to take notes, copy examples, and be ready to complete your homework for lesson 4 in class the next day. Alright, that's it.